So we've populated our SSB schema. It's fully populated in the column store. It's actually also fully cached in the buffer cache, not that we're too worried about that performance comparison at this point. And we've shown you how we do scans. So we've kind of gone through the basics of database and memory. And so now let's take a look at a traditional hash join. So I've got the no in-memory hint, because with the tables I am going to query are part of the column store. So we want to avoid that to show just a traditional hash join and what it might look like. It takes a few seconds since we're not doing in-memory on actually 16 on our demo. But notice now we have the same basic query that we had in the example. And we see our hash join here. The first table will be our build table, date dimension table, and it's smaller than the line order table, which is our fact table. And we do our hash join. In this case, we'll do a sort and return those rows back to the query, which were right there. We were looking for revenue. So now let's take the same.
Andy, before you move on, I noticed you used the no in-memory hint, but is there anything else in the execution plan that indicates the in-memory column store was not considered or used for this query?
Yeah, good point. Well, it was not considered. Yes, it was not considered in the sense that we have our table access full, so we don't see table access full in memory or table access in memory full. So we know that we didn't actually access the column store as well. Good point. Yeah, that was lesson or office hours 2, but that's always good to review. Thank you.
Well, I missed office hours 2, so you have to forgive.
No, that's fine.
You have to forgive me on that one.
No, because folks, well, that's a good point, because folks that come in maybe haven't looked at some of the other sessions, and is a good review to show that, yeah, this didn't use database and memory. And the main reason we did that, or I did that, was so that we wouldn't, I'll actually show you why, because when we actually don't put our in-memory hint in, not only does it run screaming fast, but what we now see is not only our table access in-memory full, but because we did take advantage of database and memory, then we see the join filter create with our Bloom filter and our join filter use with our Bloom filter. Now, the reason I wanted to run the demo in this particular case is I also wanted to show you that in the predicate information, you notice that we have our in-memory, and we kind of reviewed this prior, but what we'll see now is we'll see both the traditional filter predicates that we would see with without database and memory, but it will tell us what we leverage for filter predicates in memory. And that's very key, because notice that we have the sysop Bloom filter function here, which tells us that we actually used our Bloom filter we created in step 3, and then used it in step 5, but applied it in step 6 to the actual scan of the line order table. So this is how we know that we actually use that Bloom filter as part of the scan. And notice, in addition to that, our other filter predicates that we have. So when it's not an all or nothing kind of thing, we can actually use other filter predicates all combined together to scan the line order table, and hopefully do as much, if not all, of the work that we need to do for the query during the scan and filter operation.
And if we go back up to your query, are you saying then that that LO order date is the join column? That's why we're creating the Bloom filter on that? Was that your join column between the two tables?
Yeah, so we have LO order, line order, and date dim.
Yeah.
And then we have, this is our equality predicate.
Okay.
Right? And then we have actually on our date dimension table, we have filter predicate here, so we can create our Bloom filter. And then we have our other filter predicates that were included on the scan.
Perfect. So that's why it's LO order date in your Bloom filter, because that's the join column. Makes sense.